So in this video we're going to graph linear equations that are written in the form ax plus by equals c, and we're going to graph them by finding the intercepts, so it's the same thing that we were doing in previous videos, and we're going to work with the case where we have nice easy integer intercepts to begin with. Before we jump into drawing the graph though, what we want to identify is that this form ax plus by equals c is what we're going to call the standard form of a linear equation. The definition of standard form of a linear equation varies a little bit from textbook to textbook, from person to person. So unfortunately, standard form doesn't have maybe a standard definition. For our purposes, what we're going to identify is that in standard form, we're going to let A, B, and C be elements of R. And when you see R written this way, this just represents real numbers. So this means any number that lives on the real number line. So what we're allowing for is A, B, and C to be any number on the real number line. So they could be integers, they could be rational numbers, they could be irrational numbers like the square root of 2 or pi or Euler's number. So we're allowing for A, B, and C to be anything that lives on the real number line. We're not allowing A, B, or C to be a complex number that has anything other than a 0 on the I term. And the other thing that we're doing, because we're wanting to call this the standard form of a linear function, we can't let B equal 0. If B equals 0, we get a vertical line, and we've already seen in previous videos that a vertical line isn't a function because it clearly fails the vertical line test. If we allowed B to equal 0, then I would need to change this and say, hey, this is the standard form of a linear equation or relation, a linear relation, but it's not a function. So for our purposes, we're not going to let B be 0, and we're going to let A, B, and C be any real number with that one exception that B can't be 0. So we're going to start off by graphing this function, linear function, which is written in standard form 3y plus 2x equals 12. We're going to graph it by finding the intercepts, so the same technique that we used for functions that were in slope-intercept form. We're going to see some different techniques later on, but the concepts are the same. The concept is, hey, for the y-intercept, if you're on the y-intercept, you know that the x-coordinate is equal to 0. So if you're looking for the y-intercept, you know that x has to be 0, and you're looking for the y value that pairs with x equal to 0. So the way that we do this is we take our linear function, 3y plus 2x equals 12, and to find the y-intercept, we just replace the y value with a 0. And then we solve for the variable y to figure out the other number that goes into the ordered pair, or the y-coordinate that needs to go into the ordered pair. So 2 times 0 is 0. We wind up with 3y equals 12. And then we divide both sides by 3 to get y equals 4. So the y-intercept is going to be the ordered pair. When I input x equal to 0, the output is y equal to 4. And then we play the same game and we get the x-intercept as well. And what we want to remember is that on the x-intercept, where we cross the x-axis, we may not know what x is, but y must always be 0 when it's on the x-axis. So we just take our linear function, 3y, but we replace the y with 0 because we know the x-intercept has a y-coordinate of 0 always. And then we go plus the 2x equals 12, and we just solve it for x. So 3 times 0 is 0. 0 plus 2x is 2x. 2x equals 12. Divide both sides by 2. We get x equals 6. And now we have our x-intercept and our y-intercept. So to do the graph, I just establish my x and y axes. I make sure I put arrows on the axes. I try to draw straight without having a ruler. And then I want to eyeball these before I do anything. 0, 4 is going to be plotted on the vertical axis or the y-axis. I should include my axis labels. and 6, 0 is going to be plotted on the x-axis. So I'm going to need to be a little bit wider than I am high. So I'm just going to draw a line that intersects y. A little, 4 units up needs to be a little less high than this is going to be wide. And I have 4 units and 6 units. So you just eyeball it. And then if you don't like it, just try again until you get something you think gives you roughly a 4 and a 6, or that 2 to 3 ratio. Again, I don't put the tick marks in first unless I have a ruler. I think it's okay to tick this out, and if I have a ruler, but I don't have it, so it's going to be, if I'm freehand drawing, it's easier to draw the line first and then mark in the intercepts after the fact. So this was input 0, output 4 for my y-intercept, and it was input 6, output 0 for my x-intercept. And then I am done with my graph. I just double check that I remember to put the arrows on everything. I did. Did I label the intercepts? I did. Did I label the axes with x and y? I did, so that's done. And then it says find the domain and range, but this is a linear function and it's not a horizontal line, so we know that the domain and range by previous work, as long as it's not a horizontal line, that a linear function is going to have domain x as an element of the open interval from negative infinity to infinity, and we know that the range is going to be y is also an element of the open interval from negative infinity to infinity. That's by previous work. We could also determine that by looking at the end behavior of this function, and end behavior is something that we've discussed in a previous video.